When considering running electrical wiring, the decision between underground and overhead installations often depends on various factors, including local regulations, site conditions, cost, and safety considerations. In the specific case of running wiring through or near a dike, additional scrutiny is warranted due to the potential for water exposure, soil instability, and the dike's primary function in flood control. Underground wiring offers several advantages, such as reduced exposure to weather-related damage, improved aesthetics, and a lower risk of contact with overhead objects. However, it also presents challenges, particularly in areas prone to flooding or with unstable soil conditions. Dikes are engineered structures designed to prevent flooding, so any penetration or disturbance must be carefully evaluated to ensure the dike's integrity is not compromised. Running electrical conduits underground through a dike requires meticulous planning and execution. Firstly, a thorough geotechnical investigation should be conducted to assess the soil composition and stability. This investigation will help determine the appropriate type of conduit and burial depth. Secondly, the conduit must be waterproof and resistant to corrosion to withstand the harsh underground environment. High-density polyethylene, Schedule 80 polyvinyl chloride, or rigid metal conduit with appropriate coatings are commonly used for underground electrical installations. Thirdly, the conduit should be buried at a depth that complies with the National Electrical Code and local regulations. The NEC typically specifies minimum burial depths based on voltage levels and the type of installation. Fourthly, the trench for the conduit should be carefully excavated and backfilled to avoid disturbing the dike structure. Compaction of the backfill material is crucial to prevent settling and erosion. Fifthly, warning tape or other marking devices should be installed above the conduit to alert future excavators to the presence of underground utilities. Sixthly, regular inspection should be conducted to monitor the condition of the conduit and the surrounding soil. Overhead wiring, on the other hand, involves running electrical conductors above ground, typically supported by poles or other structures. While overhead wiring is generally less expensive to install than underground wiring, it is more susceptible to damage from weather, trees, and other external factors. In areas prone to flooding, overhead wiring may be a more resilient option as it avoids direct contact with floodwaters. However, the height and clearance of overhead wires must comply with the NEC and local regulations to ensure safety and prevent contact with vehicles or equipment. When considering overhead wiring near a dike, it is essential to ensure that the poles or support structures do not compromise the dike's stability. The pole should be located far enough from the dike to prevent erosion or damage. Additionally, the wires should be installed at a height that allows for safe passage of vehicles and equipment. The NEC provides guidelines for the minimum clearance of overhead wires above roadways and other areas. Both underground and overhead wiring installations must comply with the NEC and local regulations. The NEC provides detailed requirements for conductor sizing, overcurrent protection, grounding, and other aspects of electrical installations. Local regulations may impose additional requirements or restrictions based on specific site conditions or environmental concerns. Before undertaking any electrical work, it is essential to consult with a licensed electrical contractor and obtain the necessary permits from the local authorities. An electrical contractor can assess the site conditions, develop a detailed installation plan, and ensure that the work is performed in accordance with the NEC and local regulations. Obtaining the necessary permits ensures that the installation is inspected and approved by the local authorities. The integrity of a dike is paramount for flood control. Any penetration or disturbance of the dike structure must be carefully evaluated and mitigated. Consulting with a geotechnical engineer or other qualified professional is crucial to ensure that the electrical installation does not compromise the dike's stability. The NEC addresses requirements for underground installations in Article 300.5, specifying minimum burial depths, conduit types, and other considerations. For example, direct buried cables must be buried deeper than conduit and case cables. The specific burial depth depends on the voltage level and the type of installation. For example, a 120 volts or 240 volts circuit may have a different burial depth requirement than a 480 volt circuit. The NEC also requires that underground cables be protected from physical damage. This can be achieved by using rigid metal conduit, intermediate metal conduit, rigid polyvinyl chloride conduit, or other approved methods. The choice of conduit depends on the site conditions and the level of protection required. Grounding is a critical aspect of electrical safety, both for underground and overhead installations. The NEC requires that all electrical systems be properly grounded to provide a low impedance path for fault currents. This helps to protect people and equipment from electrical shock and fire hazards. For underground installations, the grounding electrode conductor must be connected to a grounding electrode system such as a ground rod, ground plate, or underground metallic water pipe. The grounding electrode system must meet the requirements of NEC Article 250. For overhead installations, the grounding electrode conductor must be connected to a grounding electrode system at the service entrance. The grounding electrode system must meet the requirements of NEC Article 250. Overcurrent protection is another essential aspect of electrical safety. The NEC requires that all electrical circuits be protected by overcurrent devices, such as fuses or circuit breakers. Overcurrent devices are designed to interrupt the flow of current in the event of a fault or overload. This helps to prevent damage to equipment and reduce the risk of fire. The size and type of overcurrent device must be appropriate for the circuit it is protecting. The NEC provides guidance on selecting the appropriate overcurrent device for various types of circuits. In addition to the NEC, local regulations may impose additional requirements for electrical installations. These regulations may vary depending on the jurisdiction and the specific site conditions. It is essential to consult with the local authorities to determine the applicable regulations before undertaking any electrical work. Permits are typically required for electrical installations, and inspections are conducted to ensure compliance with the NEC and local regulations. The permit process helps to ensure that the electrical work is performed safely and correctly. Inspections are conducted by qualified electrical inspectors who verify that the installation meets the applicable codes and standards. Proper planning and execution are essential for a successful electrical installation. This includes selecting the appropriate materials, using qualified personnel, and following all applicable codes and standards. A well-planned and executed electrical installation will provide reliable and safe power for years to come. Regular maintenance is also important to ensure the continued safety and reliability of the electrical system. This includes inspecting the wiring, connections, and overcurrent devices for signs of damage or wear. Any necessary repairs or replacement should be performed promptly to prevent potential problems. The decision between underground and overhead wiring should be made based on a careful evaluation of the site conditions, the applicable codes and standards, and the specific requirements of the project. Consulting with a licensed electrical contractor and obtaining the necessary permits are essential steps to ensure a safe and successful installation. Furthermore, understanding the role and function of the dike is crucial. Altering or compromising the dike structure can have severe consequences, potentially leading to flooding and property damage. Therefore, any electrical work near or through a dike must be approached with utmost caution and expertise. The impact of the installation on the surrounding environment should also be considered. Underground wiring can disrupt soil and vegetation, while overhead wiring can impact wildlife and aesthetics. Effort should be made to minimize the environmental impact of the installation. This may involve using environmentally friendly materials, restoring disturbed areas, and implementing erosion control measures. In summary, the decision to run electrical wiring underground through a dike or overhead requires careful consideration of various factors, including safety, regulations, cost, and environmental impact. Consulting with qualified professionals and obtaining the necessary permits are essential steps to ensure a safe and successful installation. The integrity of the dike must be protected, and the environmental impact of the installation should be minimized. The NEC provides comprehensive guidance on electrical installations, and local regulations may impose additional requirements. By following these guidelines and working with qualified professionals, it is possible to install electrical wiring safely and effectively in challenging environments such as dikes. Remember that working with electricity can be dangerous. Always follow safety precautions and consult with a qualified professional before undertaking any electrical work. The National Electrical Code, or NEC, serves as the cornerstone for electrical safety in the United States. It's a comprehensive set of standards published by the National Fire Protection Association, or NFPA, aimed at safeguarding people and property from electrical hazards. The NEC isn't law itself, but it's widely adopted by state and local jurisdictions, becoming the legal standard for electrical installations. It covers virtually every aspect of electrical wiring, from conductor sizing and overcurrent protection to grounding and wiring methods. It's regularly updated to reflect advancements in technology and evolving safety concerns. Compliance with the NEC is essential for ensuring electrical safety and preventing fires and injuries. Electrical codes and standards are essential tools for ensuring the safe and reliable operation of electrical systems. These codes and standards provide detailed requirements for the design, installation, and maintenance of electrical equipment and wiring. They are developed by organizations such as the National Fire Protection Association, the Institute of Electrical and Electronics Engineers, and the American National Standards Institute. Compliance with these codes and standards is essential for protecting people and property from electrical hazards. The NEC outlines specific requirements for different types of wiring installations, including those in hazardous locations, healthcare facilities, and other specialized environments. These requirements are designed to address the unique challenges and risks associated with each type of installation. For example, wiring in hazardous locations must be explosion-proof to prevent ignition of flammable gases or vapors. Wiring in healthcare facilities must be designed to minimize the risk of electrical shock to patients. The NEC also addresses the use of renewable energy sources, such as solar and wind power. It provides requirements for the installation of solar panels, wind turbines, and other renewable energy equipment. These requirements are designed to ensure the safe and reliable integration of renewable energy sources into the electrical grid. In addition to the NEC, there are other important electrical codes and standards that may apply to specific projects. These include the National Electrical Safety Code, which covers the safety of electrical utility systems, and the IEE standards for electrical power systems. It's important to be familiar with all applicable codes and standards before undertaking any electrical work. Failure to comply with these codes and standards can result in fines, delays, and even legal liability. Moreover, compliance with electrical codes and standards is not a one-time event. Electrical systems must be regularly inspected and maintained to ensure continued compliance. This includes checking wiring, connections, and overcurrent devices for signs of damage or wear. Any necessary repairs or replacement should be performed promptly to prevent potential problems. The NEC is not just a set of rules, it's a living document that evolves with technology and experience. Regular updates incorporate new safety measures and address emerging challenges. Staying current with the latest edition of the NEC is crucial for electrical professionals and anyone involved in electrical work. Proper grounding is a critical aspect of electrical safety. Grounding provides a low resistance path for fault currents to return to the source, tripping over current devices and preventing electrical shock. The NEC specifies detailed requirements for grounding electrodes, grounding conductors, and bonding. These requirements are designed to ensure that electrical systems are properly grounded and that fault currents are safely conducted back to the source. Overcurrent protection is another essential safety measure. Overcurrent devices, such as fuses and circuit breakers, are designed to interrupt the flow of current in the event of a fault or overload. This prevents damage to equipment and reduces the risk of fire. The NEC provides guidance on selecting the appropriate overcurrent device for various types of circuits. It's important to choose overcurrent devices that are properly sized and rated for the circuits they are protecting. Electrical safety is not just the responsibility of electrical professionals. Everyone can play a role in preventing electrical accidents. This includes using electrical equipment properly, avoiding overloading circuits, and reporting any electrical hazards to the appropriate authorities. By working together, we can create a safer electrical environment for everyone. If working near water, it is important to know your local regulations and to take all safety precautions seriously, and that nothing in this narration should override the guidance of a certified electrician or certified construction expert.